Hi, I'm Emily.
And I'm Casey.
And this is our physics project. The three elements that we decided to elaborate on is the conservation of energy,
friction, and centripetal force. First, we'll start off with the conservation of energy. The rule of conservation of energy states that energy can neither be created nor destroyed. Therefore, the ball won't come back any farther than either of its endpoints from where it was originally brought. So the type of energy on the ball will change, but the total energy, like the total amount of energy, will not. Therefore, the ball will have more potential energy here, more kinetic energy here, and more potential energy here again. As Emily holds the ball up to her nose and lets it go, it will not come back any farther than it was originally brought, so it will not hit her in the face. Go ahead. Alright, now this time, when Emily pushes the ball, it will come back farther because more energy was originally given.
Our second experiment that we decided to do is friction. Friction is the action of one surface area or object rubbing against another. Our friction experiment was to fill one bottle with rice and then move a pencil up and down inside the bottle to rearrange the rice to create friction, and result being able to lift the bottle of rice with a pencil. Each time you push down the pencil, the rice in the jar is compacted against the other grains of rice, against the pencil, and against the sides of the jar. When this is done repeatedly, then all the little air pockets in the jar shrink and the grains of rice fit together nicely and cannot move. This increases the surface area, which gives the rice a greater normal force and making friction larger. This also increases the friction between each grain of rice and the grain in the pencil, as well as between the rice and the sides of the jar. Once the surface area is and the combined friction of the rice and the sides of the jar, the force of the friction will become greater than the combined weight of the rice in the jar, and thus the jar will be lifted by the pencil. So, you take your rice and you fill your jar. And then once you have the rice in your jar, you take your pencil, stick it in, and move it up and down multiple times. This can take about 15 minutes, so this is why we're not showing you the entire experiment. In the end, it'll look like this. This has already been compacted. You will shove in your pencil, maybe. When you move them all together, the friction between the rice, the sides of the jar, and the pencil is more than the weight of the rice in the jar. And that's friction.
Centripetal force was our third project to do, or example. Centripetal force is a force that acts on a body moving in a circular path and is directed towards the center around which the body is moving. In our example, the cup is the normal force keeping the body, or the marble, in a circular path because it is pushing towards the middle of the cup, whereas the velocity is pushing in a straight line. If at any point in time we were to stop the cup and look at the marble, the normal force would be pointing in and the velocity would be pushing out of the cup. So when we take the cup, or the normal force, away from the equation, all that is left is velocity and inertia, so the marble will travel in a straight path. For an example, we have the wine cup and the marble. Alright, when we stopped the cup, the marble, with so much velocity and no more normal force keeping it in the circular path with the centripetal force, went off in a straight line along with inertia. And that's centripetal force.
So, to sum up, our first one was the conservation of energy, which means that energy cannot be created or destroyed. And so it'll start and end in the place where it was dropped. But if energy is added at the beginning of the equation, then it might travel a little bit farther.
Alright, our second one was friction, and there was so much friction caused between the jar, the rice, and the pencil that it created enough surface area to outweigh the rice and the jar so that the pencil could pick up both the rice and the jar at the same time. And our last one was centripetal force. Centripetal force was when we spun the cup and the marble went around inside the cup with enough, because the normal force had more force, a stronger force pushing in on the marble than the inertia or the velocity did when it was trying to escape the cup.
And that is our physics project. first one was the conservation of energy, which means that not power. What is it? God damn.
All right, Emily. Now, when you drop the ball this time, it shouldn't come back and hit your face because there was no more energy used than is given. So if you just drop it, it should not hit you in the face.
No, I'm not using it anymore. You do that, kid.
We live in a greedy little world that teaches every little boy and girl